Hello, this is Mrs. Claycamps and Ms. Hobbs Applied Physics class, and we are currently covering Chapter 16.2, How Motors and Electricity Work. And we wanted to cover this image first before we went over the definitions because this makes a lot more sense than the definitions. So what we've got is we've got a wheel, and in the wheel there is a magnet, and this is the north part of the magnet, and this is the south part of the magnet. And they're placed every other portion of the wheel. And this rotating disc is what is called a rotor. You've heard of rotors before, rotors in motorcycles or rotors in cars. A rotor is a spinning disc of some kind. And in the lab that we're going to do, hopefully tomorrow, we're going to be using a rotor to generate electricity. Okay? And just like in the electric motors that you use with the coil of wire around it, what's happening here is that this north pole is attracted to this south pole. And as it spins, this one moves up, which is actually a south pole, and this south pole is repelled by this south pole. So it's a alternating of attract, repel, attract, repel, attract, repel, attract, repel. So once you get it spinning, you have a constant force going, okay? So we've got opposite poles of the magnets, and we've got a rotor, and that's going to make the next slide a little bit more make sense. Here, let's go with this one. So this is the lab that we're going to do, and this is what a generator would do, okay? And we have generators on bicycle wheels that actually can run lights or charge cell phones. Okay, so electric motors convert electrical energy into mechanical energy. They do some kind of work, which is what we talked about in the energy unit. The disc, the rotating disc, is called a rotor because it can rotate. And the disc will keep spinning as long as the external magnet is reversed every time the next magnet in the discs pass by. So if you had a alternating current running by that wheel, you would be able to keep the wheel in perpetual motion because the alternating current would apply attraction and repulsion forces each time. One or more stationary magnets reverses their poles to push and pull on a rotating assembly line. So here we've seen these stationary magnets moving, but you could also have a current, an alternating current with a wire going through that, and you would get the same effect. Okay. The process of reversing the current in the electromagnet is called commutation, and the switch that makes it happen is called a commutator. Okay, so here's your rotor with your disc, here's your permanent magnets, here's your electromagnet, here's your south pole, which is attracting the north pole and repelling the south pole here. And then as it switches, you've got the attraction or repulsion taking place. That switch that takes place is called the commutator, and the thing that reverses the current in an electromagnet is called a commutation. We use electric motors in lots of things. The classic example is a blender. You're spinning a shaft, which spins the blades, which chops up whatever you need to chop up. All types of electric motors have three key parts: a rotating element, a rotor with magnets, a stationary magnet that surrounds the motor, and a commutator that switches the electromagnets from the north to the south at the right place to keep the rotor spinning. So in a blender, you change the speed of the commutator, you change the speed of how fast the shaft is rotating and how fast things get chopped up. Okay? So we've got alternating AC and DC motors. Motors that run on alternating current electricity are easier to make because the current switches direction all by itself. You don't need a commutator. So this is a direct current motor. And you've got the electromagnetic coils in there. You've got the commutator here. And you've got the shaft there that would spin. And you see the permanent magnets off to the sides. The rotating part of the motor, including the electromagnets, is called the armature. You've got the electromagnet here, permanent magnet here, and the armature, which is moving this electromagnet to move the shaft. There's 3 electromagnets that correspond to the 3 coils. You've got a coil here, you've got a coil here, and you've got a coil here off to the side. The permanent magnets are on the outside, and they stay in a fixed place. The wires from each of the 3 coils are attached to 3 metal plates, a commutator at the end of the armature. So you've got the brushes here, which allow the electrical signal to keep in contact. So in other words, you're not getting a twine of wires that's taking place. You've constantly got electrical current because the brushes can move. And what's happening is you're creating electromagnets, and you've got a south pole. So this is going to repel and also attract as it goes through. And these parts, let's go back one, is the commutator. Okay? So you've got the metal that's going on right here to change the currents. All right, as the rotor spins, the 3 plates come into contact with the positive and negative brushes that allow the electric current to flow. Electric current flows through brushes into coils. So the 3 main parts of electromotor is the rotor, the fixed magnets on the rotor, and the electromagnet, and either the electromagnet that's alternating current. If you have alternating current, you don't need a commutator. If you have direct current, you need a commutator. Okay? And the commutator switches the direction of the current in the electromotor at the right time. All right. This is what you really need to have in your notes, and we will be going over how to work motors tomorrow, and hopefully we'll have a lab for you.